Welcome to another safety class, and today we're going to be talking about personal protective equipment, or PPE. So how do we protect employees from workplace hazards? What are the different methods that should be adopted to protect them from any accidents or incidents? Employers must protect employees from hazards such as falling objects, harmful substances, and noise exposures that can cause injury. The different methods to do that is, first of all, use all feasible engineering and work practice controls to eliminate and reduce hazards. So we're going to redesign our process, the operation itself, trying to see if it can be done in a different way that's going to be less hazardous to the employees. And the second method is going to be to use the personal protective equipment, PPE, if the controls do not eliminate the hazards. So if we've done our best, but still the job is going to be hazardous, like for example erecting steel for a steel structure. Of course, people are going to be working at a higher altitude and they do not have any kind of protection. The operation cannot be redesigned or can be arranged in a different way. Therefore, we'll have to rely on personal protective equipment to protect them from falling in this case. Therefore, PPE is going to be our last level of control, not the first but the last. The engineering controls that we talked about can include something like initial design specifications. We can see if we can change the designs. For example, if there's a hazardous material that they have to deal with, is there any other material that's less hazardous or not hazardous at all that can do the same job? Substitute with less harmful material if again that can be provided. Change the process or enclose the process. For example, if there's going to be some fumes, if there's going to be some sparks, if there's going to be some debris, if we can enclose it by putting some shields around the operation itself, that can protect the other employees on site. Or isolate the process. So all of these are engineering controls that can be adopted in redesigning the process itself to minimize the exposure of the employees. So the work practice controls, if the employees can change the way they do their jobs and the exposure to the potential hazard is removed, then the hazard can be eliminated with the work practice control. Just to give you an example, when you are lifting a heavy object, there's a proper way of lifting it and there's a wrong way of lifting it. So the proper way is to bend the knees and to let the legs carry the load rather than the back. The improper way or the incorrect way of doing it is to lock the knees and put all the load on the back. So therefore, it's just the work practice control without the provision of any personal protective equipment or anything, just by teaching people how to do the job in a more correct way that can reduce the amount of injuries. So the responsibilities in this case are going to be dual responsibilities. There are going to be some responsibilities on the employer and some on the employee. For the employer, you have to assess the workplace for hazards, determine exactly where the hazards are. The employer has to provide the PPE that's part of the employer responsibility if the employee is going to be subject to any of the job hazards, and there's a PPE that can protect from these hazards. It's the employer's job to provide that PPE. And determine when to use, what are the conditions for using that PPE, and provide PPE training for employees and instruction in the proper use of that PPE. Again, something like a gas mask, for example, or something like air supply. You have to train people on how to use it because by default they wouldn't know how to use it without having that proper training. On the other hand, the employee's responsibilities are going to be to use the PPE in accordance with training received and other instructions, and to maintain that PPE and to keep it in good working conditions through inspecting it daily and maintaining it in a clean and reliable condition. Some examples of PPE, personal protective equipment for the different body parts. For example, for the eyes, we're going to have the safety glasses, we're going to have the goggles, we're going to have the welder's mask, for example. For the face, we're going to have the face shield. For the head, we're going to have the hard hats. For feet, we're going to have safety shoes or steel toe shoes. For the hands and arms, we might have different kinds of gloves depending on the operation, as we're going to see in a few minutes. For bodies, we're going to have vests. And for hearing, we're going to have either earplugs or ear muffs depending on the sound intensity. The PPE program includes procedures for selecting, providing, and using the PPE. First, assess the workplace to determine if hazards are present. Again, that's the responsibility of the employer, which is going to be followed by the employee as well, or are likely to be present, which necessitate the use of PPE. And after selecting the proper PPE for that kind of operation, provide training to the employees who are required to use it. If employees are required to use PPE, train them. Why is it necessary? How it will protect them? What are its limitations? Because again, there's nothing that's foolproof. There's nothing that's going to provide 100% protection without following the proper instructions. When and how to wear it, how to identify signs of wear if it's not working properly, and how to clean and disinfect in case it gets contaminated, and what is its useful life and how is it disposed of. Because again, even the hard hat, when you look on the inside of the brim of the hard hat, you're going to find a stamp that shows when it was manufactured and for how long is it going to be valid, basically because of the exposure to the ultraviolet rays from the sun and so on, that can render the hard hat too brittle. So in this case, it has to be replaced. The first step is going to be the head protection, and the most famous protection is going to be the hard hat. Causes of head injuries include falling objects such as tools, bumping head against objects such as pipes or beams on construction sites, contact with exposed electrical wiring or components. So hopefully the hard hat is going to protect from all of these to a certain extent. The eye protection, and as you can see here, we have double eye protection through the shield and through the goggles. When must eye protection be provided? When any of these hazards are present, dust and other flying particles such as metal shavings or sawdust in wood operations or in welding operations or cutting operations, corrosive gases, vapors and liquids, especially when working near chemicals, molten metal that may splash, again, welding or foundry operations, potentially infectious materials such as blood or hazardous liquid chemicals that may splash, and intense light from welding and lasers. In this case, eye protection is going to be required, but as you can see from this list, not every eye protection is going to protect from all of these hazards at the same time. So each one has its own kind of protection. The criteria for selection include what hazards is it going to be protect against, because again of the specificity of these different PPEs. So protect against specific hazards, comfortable to wear, because again if it's going to be causing some irritation or some discomfort in wearing, people are going to tend to remove it when working, and that defeats the whole process. Does not restrict vision or movement, so again it's going to allow for front vision and lateral vision as well. Durable and easy to clean and disinfect, that's the job of the employee who's going to maintain that PPE, and does not interfere with the function of other required PPE. So if you're going to have, for example, a gas mask or an air supply device or something like that, there shouldn't be any conflict or any interference between the eye protection and any other PPE in this case. Ordinary glasses do not provide the required protection because the lenses can shatter, for example, upon impact or upon being hit by something, and they cannot provide the proper shading as well. Proper choices include prescription glasses with side shields and protective lenses to cover the side of the eyes as well from any debris. Goggles that fit comfortably over corrective glasses without disturbing the glasses. So in addition to wearing the glasses, you're going to wear the goggles on top of them. And goggles that can incorporate corrective lenses mounted behind the protective lenses. So it's going to act as an eyeglass and as a protective goggle at the same time. The safety glasses are going to be made with metal and plastic or plastic safety frames. Most operations require side shields like what you have here on this set of glasses. It has a wraparound lens, so it's going to cover the sides as well. It's used for moderate impact from particles produced by jobs such as carpentry, woodworking, grinding, and scaling. So minor flying debris or sparks or something like that, so it's not something major, something heavy. The goggles, on the other hand, are going to protect the eyes and area around the eyes from impact, dust, and splashes, so these are going to be much more heavy duty, and some goggles can fit over corrective lenses, as we just discussed in the previous slide. If your work is going to involve working with laser in a lab or something like that, then definitely we're going to need some additional kind of protection. So we're going to have laser safety goggles, which are, as you can see, darker in color and more shaded to protect against the laser brilliance, and they have the side protection as well, so either goggles or glasses. So the laser safety goggles are another means of protecting from laser rays, as we just mentioned. Face shields are the third way of protecting the eyes and the face in general. They're going to cover the full face and protect the full face accordingly. Protects face from dusts and splashes or sprays of hazardous liquids. Does not protect from impact hazards, because again, this is not designed to protect from the impact of a heavy material or heavy tool, for example. You can wear safety glasses or goggles underneath to add additional protection for the eyes. Welding shields are a very specific type of face shields. They protect the eyes against burns from radiant light. They protect the face and eyes from flying sparks, metal spatter, and slag chips produced during welding, brazing, soldering, and cutting. So they're going to have a better impact resistance than the other face shields, and they're going to protect from the radiant light from these different operations. Hearing protection, that's another PPE kind of device that we're going to have to provide if the employees are going to be exposed to an elevated noise level on a regular basis and for a prolonged period of time. So when it's not feasible to reduce the noise or its duration, use ear protective devices. And ear protective devices must be fitted. They have to fit properly to protect the eardrum and the hearing in general. And here it shows, for example, some different noise levels. Speaking voice would be anywhere between 60 and 70 decibels. A bulldozer is going to be 85 decibels for an insulated cab for the operator who's working inside that insulated cab. A welding machine is going to be anywhere between 85 and 90. Grinder 86. Loader backhoe in an insulated cab a little bit higher than the bulldozer, 87. Crane in insulated cab 90. Compactor, no cab, 94. Masonry saw 95. Quick cut saw, and you can see a jackhammer, for example, is going to be 96. A pile driver, which is going to be the loudest noise, is going to be 112. So you have to provide protection. It's recommended above 85 decibels. So for any kind of operation, basically above speaking voice, you're going to need hearing protection, because it's going to be an extended exposure. And if it's going to be above 105 decibels, like a bulldozer with no muffle, impact wrench, air arcing gouging, pile driver, then you have to provide double protection, which is about anywhere above 105 decibels. So when must hearing protection be provided? First of all, after implementing engineering and work practice controls. If we can redesign the operation, if we can eliminate the source of that noise, then we're going to do that first. If we cannot, because it's part of the job, then we'll have to provide that PPE. When an employee's noise exposure exceeds an 8-hour time weighted average with a sound level of 90 decibels. Examples of hearing protectors, we're going to have these earplugs, different kinds of earplugs. These are molded earplugs that can fit inside the ear, and they can be shaped, or the ear muffs, which are going to be a little bit more comfortable and more heavy duty, that can provide better protection. Foot protection. Here, for example, someone's working with wood, or someone working with marble, or someone working with tiles, or whatever. That doesn't seem to be wood, it's probably metal or something. So here we have the shields for the feet that protect the feet from any falling objects. When must it be provided? When any of these are present. Heavy objects such as barrels or tools that might roll onto or fall on employers' feet. Sharp objects such as nails or spikes that might pierce ordinary shoes, and these are quite abundant on construction sites. Molten metal that might splash on feet, hot or wet surfaces, and slippery surfaces. Any one of these would require a certain kind of foot protection. So we have the safety shoes that are impact resistant. They have impact resistant toes and heat resistant soles, which protect against hot surfaces common in roofing and paving, for example. Some have metal insoles to protect against puncture wounds from protruding nails. And they may be electrically conductive for use in explosive atmospheres, or non-conductive to protect from workplace electrical hazards. So again, depending on the job, you're going to find the proper pair of shoes. For hand protection, it's mostly going to be gloves, and we're going to have different types of gloves depending on the operation, whether it's going to be cutting or chemicals or hot exposure, for example. So when must hand protection be provided? When any of these are present. Burns, the probability of burns, bruises, abrasions, cuts, punctures, fractures, amputations, or chemical exposures. Any of these are going to require the use of gloves or hand protection to be used. So for example, here we have two different types of rubber gloves. The first one is nitrile, which protects against solvents, harsh chemicals, fats, and petroleum products, and also provides excellent resistance to cuts and abrasions. So that's the primary use for the nitrile or nitrile gloves. The second type is butyl, which provides the highest permeation resistance to gas or water vapors. So if it's not going to have any harsh chemicals, then we can use the butyl. A third type is Kevlar. Kevlar is a very abrasion resistant material. So Kevlar protects against cuts, splashes, and abrasion. And finally, stainless steel mesh, something like this, protects against cuts and lacerations. So here, this person is wearing on one hand a Kevlar because it's more flexible, and a stainless steel mesh to protect against a cutting surface like a knife, for example. And then we have the full body protection. As you can see here in this slide, this is called a hazmat suit, which is a hazardous material suit that's used on some operations where here, for example, they might be exposed to PCBs, which is a carcinogenic material, or in some cases asbestos or any other material that can cause severe harm. So in environmental work in general, a full body protective suit might be used. So the major causes of body injuries: intense heat, splashes of hot metals and other hot liquids, impacts from tools, machinery, and materials, cuts, hazardous chemicals, and radiation. Of course, radiation, that's a very unique type, and it's going to require its own bodysuit. So the body protection, the criteria for selection is going to be to provide protective clothing for parts of the body exposed to possible injury. The types of body protections are going to include vests, aprons, jackets, coveralls, or full body suits. Here are different examples. So here we have the jacket. Here we have the full body suit that may even protect from radiation. And here we have the apron, together with the gloves, of course. And respiratory protection, there are some written standard operating procedures. So you have to have written standard operating procedures for the proper selection, use, and care of respirators, which type is going to be suitable for which job, how is it going to be used, how it's going to be maintained, when is it going to be replaced or replenished. Possible emergency and routine uses of respirators must be anticipated and planned for, and provided the proper training to the employees. Safe use in dangerous atmospheres that must be encountered. So again, in case you are dealing with a toxic atmosphere or an atmosphere that's going to have fumes or gases and so on, then you're going to need the respiratory protection. The respirator selection. Respirators must be selected on the basis of the hazard to which the workers are exposed and according to OSHA guidelines, and they have to be NIOSH approved, which is the National Institute for Occupational Safety and Health, and they have to be fit tested by a qualified individual. Again, if you're going to have a respiratory protection device, it has to fit your face to prevent from any leaks, for example, from the sides, because if you have any of these gases or toxic fumes leaking beyond that gas mask or that respiratory protection device, then it's totally useless. So the types of respiratory protection include two general types. One is air purifying, that does not supply additional air, and the other one is air supplied when air purification is not enough and you need a constant supply of air. So the air purifying respirators must be equipped with a NIOSH approved filter. It's going to be a filter to take away the hazardous substance, whether it's a fume or a gas or something like that, by chemically reacting with it and neutralizing it. And in this case, the respirators are classified as either negative pressure or positive pressure. So positive pressure keeps the pressure inside that respirator higher than the pressure on the outside, so that that gas would not penetrate. Negative pressure is going to do the opposite, to attract that gas and then purify it through the filter. So the negative pressure air purifying are going to be two types, either the half face respirator or the full face respirator. For the half face respirator, as you can see, the eyes are exposed, so these gases are not going to be harmful to the eyes. Otherwise, it has to be a full face respirator. So fits over the nose and under the chin. Sizes from small to extra large. Again, we mentioned that it has to fit the face and the type of face. Variety of manufacturers. Secures by two ways. One goes over the crown and the other around the neck. Could go around the neck. And here are the filters that are going to react with the harmful substance and neutralize it. The full face respirator, in case that gas may harm or hurt the eyes as well. So the face piece that covers the entire face from top of the forehead to below the chin, secured by three straps. One goes over the crown, one pulls the top of the respirator up and tight to the face, and one around the neck. And it provides effective eye protection as well. The other type is the power air purifying respirator. In this case, air is blown into a tight-fitting facepiece from this air blower here. So we have a small fan, continuous flow of air. It's battery operated. Filters or cartridges are worn on either the belt, like here, or on the facepiece itself. So that's going to be a power air purifying respirator or paper. The third type is a supplied air respirator. In this case, it's not enough to purify the air, so we're going to supply clean air for respiration. Air is blown into a tight-fitting facepiece, supplies minimum of grade D air, compressed air cylinders, and is going to have an air compressor. Combination SAR may have an egress cylinder, which is a small cylinder of compressed air, usually on the worker's belt, used when the primary air source fails, because we are having full reliance on this compressed air, so we want to have some redundancy just in case this one fails. At least we have an alternative source of purified air for at least an emergency exit from the toxic environment. Another one is something like the scuba diving gear, which is air is blown into a tight-fitting facepiece, and the air tank is going to be carried on the back of the employee, supplies minimum of grade D air, and it has compressed air cylinders that are movable and carried on the back of the employee. Now, to make sure that this breathing protection works properly, we're going to have a qualitative fit test, which is going to be a chemical challenge. So to make sure that nothing is penetrating through, so we're going to have some irritant smoke or saccharine mist or Bitrax or banana oil. If the person can smell that, can smell any of these, none of these, by the way, are going to be too harmful to the person, even if they do penetrate during that test. So the wearer is asked to move and speak during the test to simulate the fit during actual working conditions. If the wearer detects the substance by irritation, smell, or taste, then obviously there's some leakage and the mask doesn't fit. It has to be replaced. The other one is going to be the quantitative fit test, which is an assessment of the adequacy of respirator fit by numerically measuring the amount of leakage into the respirator. Because in some cases, the gas might be odorless, it might be tasteless, and still it might be fatal. An example for that is carbon monoxide, as we all know. So in this case, we need to know, even if a tiny amount escapes and leaks through the gas mask, in this case, we need to know that and measure that amount. So in summary, this is the conclusion of our lecture about personal protective equipment. You might be exposed to additional details through other lectures, like we have been, for example, about fall protection when we talked about the harness and the lanyard and so on. So employers must implement a PPE program where they, first of all, assess the workplace for hazards, identify what these hazards are, use engineering and work practice controls to eliminate or reduce the hazards before using PPE. So that's going to be our first line of defense. Select appropriate PPE to protect employees from hazards that cannot be eliminated. The residual hazard that we have to face, we're going to protect against it. Inform employees why the PPE is necessary, how and when it must be worn. That's going to be done through different meetings and different training. Train the employees on how to use and care for their PPE, including how to recognize deterioration and failure. If it's not working, or if it's not working adequately, it has to be fixed or it has to be discarded and replaced. And require employees to wear selected PPE. So the issue of enforcement of the use of PPE on construction sites is of extreme importance. Making sure that everyone's wearing a goggle or eye protection, making sure everyone's wearing a hard hat if they're exposed to falling objects. If their feet are going to be exposed to hazardous material, then they have the proper footwear, and so on and so forth. That's basically our presentation today about personal protective equipment. I'll see you in another construction safety class.